In this video, we will introduce an event to our map system that we can fire whenever we want the rendering of the map to update. Let's begin by defining an event handler in our map system. To do this, we will also need to define an event args class for the event handler. We will call this class onMapEventArgs, and we will give it one reference to the world map. Remember to set the base class to the event args class from the system namespace. Now we can use this class as the template parameter for our event handler. Let's call this event handler onUpdateMapRender. Now we can fire this event for the first time right after we generate our world map. This way the rendering system can be informed that the map is ready to be rendered for the first time. We will pass the world map to the event handler in the onMapEventArgs class. Now that we have an event handler defined for this event, we can have our world render component subscribe to this event so that it can respond with the appropriate rendering update. Let's give our world render component a setupEvents method where we will handle subscribing to this event. Now let's write the method that will respond to this event when it is fired. Let's call the method updateMapRender, and we will give it the usual event signature. The first argument will be a reference to the object that fired the event, and the second argument will be a reference to our onMapEventArgs class. Now we can go ahead and subscribe to the event using this method. Let's also include the Unity onDisable callback method so that we can unsubscribe from the event whenever the world render component is disabled in the scene. We can now begin defining the response to the event using our new method. We are going to iterate through all of the cells in the world map, and then we will update each tile map based on the information that is stored in each cell. The first thing we need to do is convert our cell's position into a vector3 int, because that is what the tilemap methods will be expecting as input. We can simply initialize the vector by using the x and y values of the cell position and setting the z value to 0. We will use our references to each tile map to set the tile that is active at this position. The setTile method in the tilemap class takes the position of the cell as its first argument, and it takes a reference to the tile asset as its second argument. In order to get the tile asset, we will use the dictionaries we set up in the last video. We can look up the correct asset by using the cell's ground type, structure type, and overlay type as keys. That completes the method. This method will now run every time the onUpdateMapRender event is fired, and it will go through all three tile maps, setting the tiles to the appropriate assets. The tile map is already being displayed each frame, so there is nothing more we need to do. In order to actually see the tile maps rendered to the screen, we need to include a camera in our scene. We are going to create an empty game object called user to act as the parent of our camera. Once we have this user object, we can attach a new camera to it as a child. We are going to introduce another Unity component that will control the camera. We are going to call this component user. Let's create the script in our components folder. Let's open the script in the editor, and we will give this script a reference to our user camera. Let's also make sure we attach the script to our user game object. We will give this script a private variable that will hold a reference to the camera, and then we will include the Unity awake callback method where we will assign this reference to the camera in our scene. We will once again use the find method in the gameObject class to locate our user object, but this time we will then use the getComponentInChildren method to find the camera that is attached to it as a child. Now that we have this reference to the camera, we are going to use it to set the initial position of the camera when the scene begins. This will avoid any problems we might run into by accidentally resetting the transform of the camera, because it has to have a negative z value in order for us to be able to see the tile map. If the camera has a z value of 0, it is essentially right on top of the tile map. We need to go back to the world render component for a moment in order to make sure we actually call the setup events method in Awake. Otherwise, we would never subscribe to the onUpdateMap render event. Now, before we attempt to render the map for the first time, we need to address one more thing. We don't want to leave our tile assets in the images folder where they are now. Our code is expecting these assets to be in a tiles folder that is right at the root of the resources folder. We will create this new tiles folder and then move just the tile assets over to it. We will leave the sprites we used to create the tiles in the original images folder. We will also move the tile palettes over to the new tiles folder, but you can leave the tile atlas sprite atlas in the images folder because it is a resource that is directly associated with the images themselves. We are now ready to see our map rendered to the screen for the first time. Go ahead and press play to see the tile map. The next thing we're going to do is allow the user to move the camera around the scene. And then we will extend our map system to allow us better control over building the world map.